Hi, welcome to Micro's World. Today we are continuing with our complement system part 2 class. The major topic that we are dealing today is classical complement activation pathway. So let's begin. Complement can be activated via three pathways: classical pathway, alternative pathway, and MBL pathway. MBL pathway means mannose binding lectin pathway. Okay, in today's class we are dealing with the classical pathway. Before that, in yesterday's class have discussed in detail about the complement system and complement factor. So briefly I can recollect that complements are the soluble factors. They are circulating in an inactive or cymogenic form in our sera. Okay, so whenever an antigen is entering in our body, so this complement can be activated via three pathway. Okay, classical pathway, alternative pathway, and MBL pathway. So whatever pathway it is, the ultimate event is the formation of MAC complex. MAC means membrane attack complex. So whether the complement is activated by classical pathway, alternative pathway, or MBL pathway, the ultimate event is the formation of MAC complex or membrane attack complex. That complex get inserted into the surface of the target cell and leads to the lysis of the cell. This is the ultimate event. This is same in all these three pathway. It's a general event in complement activation. But in between this complement activation pathway, several fragments of complements will be released and they execute several other function. Okay. So the major difference between all these three pathway is in the initial event, how the complement initially get activated. There comes the difference. Okay, so let us discuss in detail about the classical pathway. For classical pathway, in order to activate the complement, it requires the formation of antigen antibody complex. Whenever an antigen, for example bacteria, enters our body recognizes it as a foreign. So our body starts synthesizing specific antibody against this antigen. That antibody will specifically go and bind with the antigen and form an antigen antibody complex. Once this antigen antibody complex is formed, that can activate the complement via the classical pathway. Not all antibody, mainly two major classes of antibody which participate in complement activation. It include IgM and IgG. Among IgG, there are four subclasses: IgG1, IgG2, IgG3, and one more is there, that is IgG4. Except IgG4, all the three subclasses 1 to 3 participate in the activation of complement via classical pathway. Okay, so before that, consider this as a bacterial cell. So whenever this pathogen enters our body study about this pathogen and synthesizes antibody against this pathogen. So this antibody specifically go and binds with the antigen. Okay, for the binding, this antibody uses its FAB portion. Okay, so once the antibody binds to the antigen by utilizing its FAB portion, there occurs a conformational change in the FC portion of the antibody. Okay, so once a conformational change in the FC portion of the antibody occurred, it exposes the binding site for the complement factor C1. So the C1 complement factor will come and binds to the FC portion of the antibody that already bound to an antigen. Okay, this is the very first event in case of a classical pathway. Okay, so even though I have said that C1 C1 complement factor. It is not a simple molecule. It is a macromolecular complex. It is made up of subunit like C1Q, C1R and C1S. 2 molecule of C1R and 2 molecule of C1S. 1 molecule of C1Q. All the subunits binds together to form a complex called C1Q-R2S2. The C1Q-R2S2 complex is stabilized mainly by calcium ion. If you look into the structure of the C1Q-R2S2 in detail, it mainly contains C1Q. Okay, C1Q is made up of 18 polypeptide chains. So, this 80 polypeptide chains, among this 3 polypeptides. So, 3 each polypeptide. 3 polypeptide like that, they form a group. Okay, so 3 polypeptide, they form triple helix. Total there are 18 polypeptide chains are there. So 3 each form a triple helix. So how many triple helix can be formed? 6 triple helix can be formed. The single triple helix, it looks like this, almost our collagen like structure. Collagen is also a triple helix structure, right? So it's similar to our collagen molecule. It form a triple helix. So this is a single triple helix structure made up of 3 C1Q polypeptide chain. So it contain a globular head. Okay, with the globular head, actually this C1Q triple helix interact with the Fc portion of the antibody. Okay, so this is one triple helix. Similarly, how many triple helix can be formed? 6 triple helix can be formed. Okay, so I can mark that. Just look into this image. See how many triple helix can be formed? 6. 1, 2, 3, 4, 5, 6. Each triple helix, this is one triple helix, this is another triple helix. Each triple helix has a stalk and a head like structure. So with the head, actually they interact with the Fc portion of the antibody. Okay, consider there is a bacteria. It is bound with antibody. Okay, numerous antibodies are there. I am just marking 2 antibody. So it exposes the Fc binding portion. So what happens? The C1Q macromolecule, with the help of their globular head, this is the globular head, right? 6 globular head they have. With that, they will bind to the Fc portion. Okay, and here also that globular head can bind to the Fc portion. In order to make a stable C1 antibody interaction, for a minimum, actually the C1Q molecule should bind with 2 Fc portion of 2 separate antibody binds to a common antigen. This is a common antigen. There are 2 antibody exposes to Fc site. Whenever the C1Q with their globular head binds to a minimum of 2 Fc fragment of the antibody, it is considered as a stable C1 Fc antibody interaction that can activate complement. So C1Q is finished. 2 other components are C1R and C1S. They basically serine proteases. Okay, so generally they have 2 domains, catalytic domain and interaction domain. With the catalytic domain, they perform the serine protease function and cleavage of the complement factor and further activation of the complement event. With the interaction domain, this subunit C1R interact with the another C1R subunit, and C1S interact with another C1S subunit, because there are 2 C1S, right? So this interaction is mainly with the interaction domain, and similarly C1R interact with the C1S and vice versa. Similarly C1R and C1S both with the interaction domain interact with the C1Q. Okay, so this is the function of interaction domain. Then I told you that mainly 2 antibody IgM and IgG participate in the activation of complement. First of all, IgM. IgM is a pentameric antibody. So this IgM can exist in either exist in two configuration, either staple configuration or planar configuration. Whenever an IgM antibody bounds to the surface of an antigen, it can exist in staple configuration. This is the staple configuration. Okay, but whenever the IgM is not bound to any antigen, it is freely circulating in the serum, it exists in the planar configuration. Okay, what is the difference between this configuration? Whenever the IgM exists in the staple configuration, that means they bounce to the antigen, it exposes the binding site for C1q complement. Okay, and whereas if the IgM exists in planar configuration, freely circulating form, it cannot expose the binding site for the C1q or C1 complement factor, and it cannot activate complement. This is the principle behind the complement as well as the antibodies. They were circulating commonly in a serum medium, but they won't activate the complement. This is the reason behind that. For example, if IgM and complements are present in the same serum, it won't leads to the complement activation, because the IgM circulate in a planar configuration, it cannot bind and activate the complement. Whereas immediately whenever the IgM binds to the surface of an antigen, what happens? It exposes the binding site for the complement. The complement will bind, especially C1 macromolecule will bind, and further activation of the complement can happen. So consider this as a bacterial cell, and this is the IgG antibody. The condition with the IgG antibody is different. Not only two IgG antibody, actually many IgG antibody can be bound to a single antigen. Okay. So whenever this IgG antibody, it recognizes a and binds to a foreign antigen, it always not leads to the activation of complement, or a minimum of nearly 1000 molecule of IgG if bounds to a target cell. For example, target cell is RBC. There is no nucleus, I will erase it. Consider the shape is also different, just consider this. If the target cell is RBC, minimum 1000 molecule of IgG if bound to the surface of RBC, it leads to the lysis of the RBC. Whereas if the RBC is bound with an IgM, consider this as an IgM, a single IgM can activate, it can bind to C1q and it can activate the complement. But in case of IgG, minimum 1000 molecules should bind. The reason is that whenever the the IgG molecule binds to the surfaces of the target cell, they are placed at different distances. For example, consider here these two IgG antibodies are closely situated. If you consider the distance between these two antibody, it is large, right? There is a huge difference. But if you consider some antibodies, they are placed at a distance between them 30 to 40 nanometer. They are 30 to 40 nanometer apart. In that case, it is ideal for the binding of a C1 macromolecule, because we know that C1 is large. In order to accommodate the C1 molecule correctly here, so that the C1 molecule can bind to the Fc portion of this antibody. As I discussed before, a single C1 should bind with the 2 Fc portion for a minimum for the effective complement activation. So in order to achieve that, these two antibodies should be placed at a distance between them 30 to 40 nanometer. This is the reason behind that a minimum of 1000 molecule of IgG if bounds to the surface of an antigen, there is a chance that very few antibody will be placed at a distance between 30 to 40 nanometer, that can facilitate the binding of C1q macromolecule, C1 macromolecule, and leads to the activation of complement. till now we have discussed the basic principle of C1q binding, the very first initial event of complement activation. So let us look into the pathway in detail. The pathway is very simple if you understand the basic principle. Before that, I'll prefer you people go back and refer yesterday's class, then it would be really helpful for you. How the complement factors get cleaved and what are the fragment released, all those things were discussed there. Okay, so anyway, the initial event, as I discussed, an antigen, this is an antigen. So what happened? An antibody recognizes and binds to the antigen. So once the antibody bounds, Fc portion get exposed. To that Fc portion, actually C1q macromolecule will come and bind. So the C1 macromolecule will come and bind. C1 contains C1q, right? So C1q have a globular head. With the globular head, actually C1q binds to the Fc portion of the antibody, and C1q often attached with the C1 2 molecule of C1r, okay, and it is associated with 2 molecule of C1s. Okay, once C1q bounds to the Fc portion of the antibody, there occurs a conformational change in C1q molecule that activate the first C1r molecule. Once the first C1r molecule get activated, it cleaves themselves and get activated because of their serine protease activity. So first C1r once activated, it can cleave and activate the second C1r molecule. Once this 2 C1r molecule get activated, they can further activate the 2 C1s molecule. Okay, once the C1s molecule is activated, there are 2 substrate for this C1s molecule. C1s molecule can cleave and activate 2 substrate, 2 complement factors. They are C4 and C2. Okay, once C4 is cleaved by C1s, it generate C4a plus C4b. C4b is the largest subunit. Once the C4b is generated mainly by the cleavage and release of the inhibitory small C4a fragment from the C4b, or simply you can say that from the C4 a small fraction called C4a is cleaved and released, so that C4b is now free. It is the active fragment, larger fragment. So once the C4b is cleaved, it is active. Now the C4b exposes its binding site, membrane binding site. So with this membrane binding site, C4b now attaches to the surface of the antigen. Especially it will attach in the vicinity of the C1q fragment, where the C1 complex bound, at the vicinity of that itself C4b bind. Similarly, C2 can also C1s can also cleave C2. Once the C2 is cleaved, it generates C2a plus C2b. C2b is the smaller subunit. So when a smaller inactive subunit cleaved off from the C2, it generates the larger subunit C2a. So this C2a now binds with the C4b. C2a binds with the C4b and form a complex called C4b2a. So the C4b2a is otherwise known as C3 convertase. C3 convertase. So this C3 convertase can further cleave many C3 molecule, not a single C3 molecule. It can cleave thousands of C3 molecule. A single C3 convertase can cleave thousands of C3 molecule, and it leads to the generation of C3a plus C3b. Once C3 is cleaved by C3 convertase, it generates C3a and C3b. And C3b is the larger subunit. What happened? This C3b further combines with the C4b2a. C3b combines with the existing complex C4b2a and form a complex called C4b2a3b. Okay, this is known as C5 convertase. C5 convertase. Okay, I can explain the same with this image. It will be really helpful for you for your exam and all. See, initially the C1q-R2S2 binds to the with their globular head, C1q globular head, they binds to the Fc portion of the antibody. Once C1q-R2S2 bind, C1q, some conformational change occurs in C1q that activates C1R, then it activates C1S. So activated C1S, see, this is the C1S, consider this as a C1S. It can cleave both C4 as well as C2. Once it cleaves C4, it releases a smaller inhibitory subunit C4A, and it leads to the generation of a larger active subunit called C4B. C4B exposes its membrane binding region. With that, it attaches to the surface of the antigen. Similarly, if this C1S cleaves the another substrate C2, it releases the small inhibitory subunit C2B from C2, so exposes the larger active subunit called C2A. So once C2A is generated, C2A combines with the C4B and leads to the generation of a complex called C4B2A. It is otherwise known as C3 convertase. So a single molecule of C3 convertase can cleave many C3 complement factor. Once C3 is cleaved, it leads to the generation of a smaller subunit called C3A and a larger subunit called C3B. So C3B further combines with the existing C4B2A subunit and leads to the formation of another complex called C4B2A3B, that is known as C5 convertase. Okay. So let's move to the rest of the events. So now C5 convertase is formed. What is C5 convertase? Simply C4B 2A 3B. This is the C5 convertase. Okay. So this C5 convertase, it cleave many C5. It cleave many C5. Once C5 is cleaved, it leads to the generation of a smaller fragment called C5A and a larger fragment called C5B. Okay. C5B combines with the C5B also exposes its membrane binding region and it binds to the surface of the membrane. Okay, it inserted to the surface of the membrane. Okay, once C5B is inserted, it acts as a binding site for the other complement components like C6, C7, C8 and all. So once this C5B this C5B binds with other activated complement components, it form a complex like C5B 6, 7, 8. Okay, that means C6 is activated and added its fragment here, C7 is activated, added the fragment here, C8 is activated, added the fragment here, and form another complex called C5B 6, 7, 8. The C5B 6, 7, 8 further inserted strongly into the membrane, and around this it facilitates the binding of another complement component called C9. You can see here many C9 binds around this C5B 6, 7, 8. Actually the C5B 6, 7, 8 facilitate the polymerization of C9 complement factor, and that form a membrane attack complex. So all this membrane attack complex firmly attached to the surface of the bacterial cell. Now this membrane attack complex, it's like a big pore that create the osmotic imbalance in the cell, because through that pore all the cellular components, ions and the fluid part will be released out, so create an imbalance in the cell. Finally it leads to the cell lysis. Okay, so this is the overall event of classical pathway. So let's meet tomorrow with the other pathway, that is alternative pathway. Okay, thank you.